Voice of the Sea, learning from experts across the ocean. Welcome to Voice of the Sea. In this special episode, we're investigating the rise and fall of marine invertebrates. Populations of animals like snails, sea stars, and sea urchins are known to increase dramatically and die off suddenly. We talk with researchers trying to uncover these mysteries. Anya Brown is studying the rise and fall of vermeted snails on coral reefs in French Polynesia. Vermetids are a special kind of marine snail that build shells attached to coral and other hard surfaces. The species that Anya studies is named Sericignum maximum for its large size. It is found in the Pacific Ocean and the Red Sea, where it is traditionally harvested and eaten. These vermeted snails trap food in mucus nets, which they lay out on top of the coral colony. Anya is interested in the effect of the snails' nets on coral growth and survival. Coral reefs are an ecosystem full of competition, where each organism battles for space and for food. Previous research shows that vermeted snails change the shape of coral growth, possibly leading to reduced habitat complexity. Scientists suspect that vermeted mucus nets contain chemicals which are harmful to the corals. Anya is conducting her studies at the Gump Research Station on the island of Moorea in French Polynesia. As we toured the reef there, I was shocked to see so many vermeted snails growing on the coral colonies. But the real issue is perhaps the environmental conditions that allowed the vermeted snails to grow in such large numbers.
Well, one of the things that I'm studying this summer is looking at the chemical effects of vermeted snails, which are sessile marine snails that produce mucus nets to capture food. But while they're putting out their mucus nets, they're also covering corals. And so my lab has done some work in the past where they've looked at the negative effects of the mucus nets on corals, and they've seen decreased growth with Mastoparades corals, Montipora, and Passalapra. And so one of the things that we might think that may be causing this decreased growth is that there's something in the nets. What I mean by something in the nets is some type of chemical, potentially. Okay. And so one of the things I'm working on this summer is looking at if there really are these chemical effects of the net. And so to do that, I've collected a bunch of nets and extracted it. And so extracting things is kind of like you soak it in alcohol for a while and then you take the alcohol off and you're left with the stuff, and you don't really know what the stuff is at this point.
Can you show me the different kinds of corals that are in your treatment?
Sure. Here's Montipora.
And what would this one grow up to look like?
So this one, when you see it in the back reef here, it usually is in cracks and crevices or in flat areas, pavement sites, but some of these, so they're pretty encrusting and can be relatively small. These I collected from the reef crust area. So this is Passalapra. Here's one that doesn't have a Band-Aid on it. These you see in their branching colonies, and some of the branching colonies are rather large. When you see fish and invertebrates, they have little guard crabs inside of them that called trapezia. They defend the coral from corallivores or other organisms that come to attack them. And then the Mastoparades is this other coral. Here's one with the Band-Aid. Whoops. You find them all over the reef. In Moorea, they're the most common coral that you see, and part of the reason why that is because Passalapra and other branching corals were the preferred food of acanthaster, the crown of thorns sea star. A couple years ago, there was a outbreak of crown of thorns, and they consumed all of the Passalapra, coroperids, and acroporas. And so acroporas were branching also, and they look kind of like Passalapra. And so since then, the reef has been really dominated by Parades roosts and Mastoparades.
And the Mastoparades is not really branching; it forms kind of those big mounds.
Right. Mm-hmm. And so vermetids you usually find them right now in Mastoparades, but I have also seen them in Passalapra and in Montipora. So they settle on dead coral usually, and then sometimes live coral can grow over the shells. Because so vermitids are kind of funny, they don't burrow into the coral skeleton, they're on top of it and secrete their shell, and then other organisms can settle on top of their shell as well as they move or as they grow upwards.
And so you mentioned that these vermitids are a snail. What does that mean? Like, what makes them a snail?
They're funny because vermitid itself, verm means worm.
Right. They
so
kind of look like
snail.
a worm.
Yeah. So if you were looking at the reef and what you're expecting is that this is a worm that makes a mucus net, but they're a snail. Mostly because of their body plan, although they're not like your typical snail that has a coiled shell. They have an elongated shell, but they have a mantle tissue and they have a modified foot that they use to make their mucus net.
Anya's field and lab research continues to show that the chemicals in vermitid nets negatively affect the photosynthesis of microalgae called symbiodinium living in the coral tissue. Surprisingly, Anya's work studying the interaction between vermitids, corals, and symbiodinium was interrupted when the vermitids began dying off. Within less than 1 month, all of the vermitids had died. Local Polynesians who eat this species report that the population similarly declined in the early 1980s. Although this die-off is alarming, scientists do hope that it may have a positive outcome on corals, which are facing a variety of stresses from overfishing and global climate change.
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
Crown of thorns is a predator that preys on coral. An individual crown of thorns can eat up to 6 square meters of living coral reef per year, and outbreaks are devastating reefs across the Pacific.
Good morning.
I have permission to come aboard.
Permission to come aboard.
We motored out of Pongo Pongo Bay on Tutuila and circled around to the northeastern side of the island to look for crown of thorns in the National Park of American Samoa. The park is one of over 400 in the U.S., and it preserves and protects coral reefs, tropical rainforests, and fruit bats. Of the park's 13,000 acres, over 4,000 are coral reefs and ocean. It is the only American national park south of the equator. Before going out on the boat, I joined Tim at the National Park Service offices for a short lesson about crown of thorns, where Tim explained how his team is planning to eradicate them.
We're having this problem on the island with crown of thorns starfish right now. We've tried physically removing them on the reef, but that takes a lot of time, and it's also slightly hazardous. You know, you have to have a diver go down, find a crown of thorn, pull it out of the reef, put it in a basket, take it to the surface, and then you have to get rid of it. Well, crown of thorns, it turns out, are highly poisonous. I've had firsthand experience. They're also very painful. So we wanted to try to reduce how much divers are interacting with crown of thorns. So something that they're doing in Australia is they're actually using a chemical called sodium bisulfate. It's a chemical used in pools to balance the pH of the pools. And they're injecting it in the crown of thorn. So we just got in today while we were down at the warehouse, our box full of injectors. This is from a company that makes these for cattle. They use them to inject cows and livestock with various things. So we're going to be trying to modify these to use on the crown of thorns here. We're getting sodium bisulfate in, and by using these we can go down now, and instead of physically removing them, the diver just carries the sodium bisulfate and these injectors and injects them into the starfish, and that will kill the starfish. Studies have shown that it's toxic for the starfish, but it's fine for the other animals out on the reef.
Because it's basically a salt, right? A sodium bisulfate.
Sodium bisulfate. It's a salt. It changes the pH, but in the starfish, you're injecting it into the starfish, so it's going to be a big change for the starfish, but not really a big change for anything around it. And we're hoping we're going to be able to get out there pretty quickly because it's the spawning season for crown of thorns.
Oh, wow.
And they can release about 10 million eggs, each female, during the spawning season. So we're trying to reduce the adult population so that in the future years, we're not getting an even bigger outbreak.
They don't move quickly and try to attack you, do they?
No, they don't move all that quickly. If a predator comes, like a Triton's trumpet, you can see them, they'll get up and they'll move quickly for a crown of thorns starfish, but that is a very, very slow walk for a person. Wow, so this is going to be our new system for hopefully controlling the crown of thorns starfish
pretty
here.
Vicious looking, Tim.
It is pretty vicious looking, but they're vicious animals. They're really spiky animals. We don't want to get close to them. So this is going to be nice because that's going to keep us a good distance away from the crown of thorns.
Go ahead, stab the box.
Ooh, there we go. And then we would just inject our crown of thorn there with a little sodium bisulfate. And we're done. So that's going to be really nice once we take this out. I'm looking forward to using this out on the reef.
What will happen to the crown of thorns after it dies from the sodium bisulfate?
Well, once it dies, it's just going to disintegrate on the reef. Other animals will come in and feed on it. So it's just going to be part of the marine ecosystem once again. And then the sodium bisulfate is just going to diffuse out into the ocean, and it's going to be gone pretty quick. Predators on a reef come in pretty quickly, so once they die, they're probably going to be consumed within a couple of days.
Tim, we're right on the edge of the national park now.
Correct. We just got here. We're at the end of the national park, and today what we're doing is we're looking for crown of thorns is our primary objective. These animals have started showing up on our reefs in outbreak levels, so we're really concerned about them. We want to find out where they are, and specifically if they're in the national park. If we're having an outbreak in the national park, we need to start doing removal efforts and get rid of them. So today what we're going to do is we're going to drop down, we're going to go down on scooters, and we're going to survey a section of the reef.
I thought that was a pretty neat dive.
Yeah, it actually went really well. So far, we've seen no crown of thorns in the national park, which we're really excited about. We have seen a lot of them outbreak levels on the south side of the island. So now that we've done surveys in the park and shown they're not here, we're going to really switch our efforts over to trying to control the ones outside the park. So in the next few weeks, we're going to be going out and trying to kill a lot of those crown of thorns, especially before the spawning season comes. We want to get them out of the population so they're not having a big reproductive input into the next population of crown of thorns, so we don't have problems in the future.
Exploring our fluid Earth is a dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group, teaching ocean science concepts through the disciplines of physics, chemistry, biology, and ecology. Exploring Our Fluid Earth is now available freely online. Find out more at exploringourfluidearth.org. You're watching Voice of the Sea. I'm at Tamai Beach with Stella Swanson and Mimi Mousley, snorkeling their study site and studying coral, algae, and sea urchin populations. Tamai and this area of Moorea used to have a very large population of the algae-eating urchin called diadema. But last year, the urchins started dying off. Stella and Mimi want to assess the population of diadema urchins this year, and they also want to see how the coral is doing without very many diadema urchins around to keep the algae under control. Stella and Mimi have tagged each of the large coral head bommies with colorful tags to easily identify them. At each coral head, we looked for sea urchins and took samples of the macroalgae growing on the coral.
That was so beautiful. All these sea urchins that you saw out there actually today were not the species that was common. So we didn't see a single one of the diadema that used to be super abundant here.
Wow.
So there used to be just around the base of those patch reefs, there would be hundreds of this black-spined urchin diadema, and we didn't see any of those today. So they don't seem to really be coming back at all, which is not that surprising. But also, good news, it looks like the algae is not coming, not growing really strong here. So that's pretty good. So we think that it could have been some sort of disease agent, so probably a pathogen that was carried in the water. But that's really just based on what we know about what happened in the Caribbean with the long-spined urchin as well. We know that that was a waterborne pathogen, but sadly they never found out for certain what caused that mortality in the Caribbean either. So it's really difficult when these things kind of happen. It sweeps through, it happens really rapidly. It's hard to collect samples of sick sea urchins to contrast with healthy sea urchins. So we don't really know. We have a bunch of samples we've collected, and we're looking for collaborators to see if they can help us analyze these for the bacterial community and the viral community, but we'll see. We don't really know, and yeah, it's a big mystery. I study sea urchins here in Moorea, and I did my master's work here, and I was studying just the role of a bunch of different species of sea urchins. So there are 5 species of sea urchins in Moorea, and there are a variety of ways that they can influence the coral reef. And about a year and a half ago, I was here doing some of my normal research, and everybody kept coming to me saying, Stella, you study sea urchins. I noticed a lot of dead sea urchins out there today. What I have here is a few photographs of the density of sea urchins before they died off. So this is at Tamai on the eastern side of the island, and this species of urchin, diadema, is really closely related to the diadema in the Caribbean.
Oh.
And you can see that there are these aggregations, really high density aggregations.
There are a lot of them.
Mm-hmm. Tons of them. There were thousands. Everywhere you swim, if you're not careful, you could really crash a knee or leg into them. But these high density aggregations like that were really common for a long time. So as long as I've been working here, about 7 years or so, they've been really dense like that.
Is it normal for them to just be scattered on the bottom like that in the daytime? I mean, normally when I think of sea urchins, I think of them hiding in the cracks and crevices, and the video I've seen of them moving around is mostly at night.
So these sea urchins normally are hiding, but when they get into these high density populations, they basically run out of space to hide. So they form these kind of aggregations as a defense mechanism from, we think, predators. They're probably, strength in numbers, safety in numbers. So they hide around the base of this structure or these patch reefs, and that's the best protection that they have. But there were so many of them there that their populations were pretty stable for a really long time, even though they were out in the open.
So it's natural for there to be this abundance of a population?
Well, we don't really know. So there are some researchers who were working in the Caribbean at the time of the diadema die-off there. Some of them suggested that it was a lack of predators that was resulting in these really high populations, because if there aren't predators there to eat the sea urchins, then the sea urchin population can grow and grow and grow.
Who eats the urchins?
Big fish. There are triggerfish are probably the most common predators. Okay. Here you can see the basically piles and piles of sea urchin spines. So there were oftentimes it was like a little ring of spines that you would find, and the broken up bits of the sea urchin test. Just thousands of spines. So you can see parts of the feeding structure here, part of the mouth. There's a tooth inside this. This is kind of just the base of one of those patch reefs around the bottom, and it's just piles of sea urchin spines. So by the time I was out here quantifying the mortality of these sea urchins, most of them were dead at that point. So there were, I would find maybe one really sick, weird-looking sea urchin every now and then when I was swimming around trying to estimate how many of them were dying and what was happening and what the benthic community looked like. So it was pretty dramatic, yeah. This is often what I was finding, what people were finding when at the time where they were saying, Stella, there's a lot of dead sea urchins. It's really weird. I don't know why they would all be, dying. And basically, you could see that it essentially looks like it rotted around the mouth on the bottom of the sea urchin. It got flipped over by a fish and everything was eaten out of it.
Can you show me a healthy one, like what it's supposed to look like?
Yeah, absolutely. So a healthy one of these sea urchins would look like this. They're really tightly aggregated against the base of the patch reef, and healthy kind of coloration, black with this iridescent blue, and their spines are all very firm and sticking out. A lot of them, when they were dying, their spines were kind of clumping together, or you could just see they were spazzing out their spines a little bit, doing kind of weird. But they're all hiding to some degree. Even if it's hiding within this aggregation, they're all in a pile together, hoping to hide from predators. This tissue essentially was the first that would go. Once it had completely died, this tissue would just totally rot out, and that Aristotle's lantern or the feeding structure would just fall out of the test. Because I work with a big research group that's interested in these coral reefs over a long period of time, we also have data sets that are really valuable that are ongoing. So we can look at, maybe there was some sudden increase in water temperature. We have some kind of nutrient samples that are taken on a yearly basis, so we can potentially look at the nutrient community if that had changed or anything like that. So we have a large data set to draw from, and at this point is basically kind of detective work, trying to figure out maybe what may have changed around that time and see if there's anything that we can piece together to find out what's going on.
And why sea urchins? What do you love about sea urchins?
Well, from kind of a practical perspective, they're really easy to study. So they stay put during the day, which is fantastic. I can count them. They're not moving anywhere. They're not biting or doing anything weird. I think that they are also just very beautiful. They're really interesting to look at, and for me, I like to study things that are very different from me. I studied physiology when I was an undergraduate in school, and I remember thinking it was really interesting to learn about the body, and I find it, studying fish, I feel like the physiology of a fish is kind of similar to ours in some ways, but an invertebrate, like a sea urchin, is so weird and so bizarre, and I just find them really fascinating because they're so different from anything that I know. Most people I talk to do not have a good experience with sea urchins, but I show them really beautiful photographs of them, and I talk to them about their importance on coral reefs, and I think people gain a little bit of different perspective from what they thought.
Bella's research shows that the diadema urchin is still absent 2.5 years after she began her study. But Stella is excited to report that the coral in the Tamai area and the other reefs most affected on the island of Moorea are still healthy. There appears to be adequate populations of important algae-eating fish that are helping to fill the ecological role of the diadema urchin and keep the reefs healthy. Thanks for watching Voice of the Sea.